Prebiotic world redirects here, but there is as yet no subdivision of this eon to reflect recent developments. The Hadean is a geologic eon of the Earth, and lies before the Archean. It began with the formation of the Earth about 4.6 billion years ago and ended, as defined by the ICS, 4 billion years ago. The name Hadean comes from Hades, the ancient Greek god of the underworld, in reference to the hellish conditions on Earth at the time. The planet had just formed and was still very hot due to high volcanism, a partially molten surface and frequent collisions with other solar system bodies. The geologist Preston Cloud coined the term in 1972, originally to label the period before the earliest known rocks on Earth. Brian Harland later coined an almost synonymous term, the Priscone period. Other, older texts simply refer to the eon as the pre-Archean. Nonetheless, in 2015, remains of biotic life were found in 4.1 billion-year-old rocks in Western Australia. According to one of the researchers, if life arose relatively quickly on Earth, then it could be common in the universe. Etymology. The Hadean was a violent period in the history of Earth, hence, it receives its name from Hades, the ancient Greek god of the underworld. Subdivisions. Since few geological traces of this eon remain on Earth, there is no official subdivision. However, the lunar geologic timescale embraces several major divisions relating to the Hadean, and so these are sometimes used in a somewhat informal sense to refer to same periods of time on Earth. The lunar divisions are pre-Nectarian, from the formation of the Moon's crust up to about 3,920 million years ago. Nectarian, ranging up to about 3,850 million years ago, in a time when the late heavy bombardment, according to that theory, was in a stage of decline. There is a recently proposed alternative scale that includes the addition of the Chaotian and Prenifoline eons preceding the Hadean. Divides the Hadean into 3 eras with 2 periods each. The Paleo-Hadean era consists of the ʻheɪdiən and the Jacobian periods. The Meso-Hadean is divided into the Canadian and the Procrustean periods. The Neo-Hadean is divided into the Akistan and the Promethean periods. Hadean rocks. In the last decades of the 20th century, geologists identified a few Hadean rocks from western Greenland, northwestern Canada, and western Australia. The oldest dated zircon crystals, enclosed in a metamorphosed sandstone conglomerate in the Jack Hills of the Narraya Gneiss Terrana of Western Australia, date to 4.404 plus or minus 0.008 Ga. This zircon is a slight outlier, with the oldest consistently dated zircon falling closer to 4.35 Ga, around 200 million years after the hypothesized time of the Earth's formation. Atmosphere and oceans. A sizable quantity of water would have been in the material that formed the Earth. Water molecules would have escaped Earth's gravity more easily when it was less massive during its formation. Hydrogen and helium are expected to continually escape due to atmospheric escape. Part of the ancient planet is theorized to have been disrupted by the impact that created the Moon, which should have caused melting of 1 or 2 large areas. Present composition does not match complete melting, and it is hard to completely melt and mix huge rock masses. However, a fair fraction of material should have been vaporized by this impact, creating a rock vapor atmosphere around the young planet. The rock vapor would have condensed within 2,000 years, leaving behind hot volatiles, which probably resulted in a heavy CO2 atmosphere with hydrogen and water vapor. Liquid water oceans existed despite the surface temperature of 230 degrees Celsius because of the atmospheric pressure of the heavy CO2 atmosphere. As cooling continued, subduction and dissolving in ocean water removed most CO2 from the atmosphere, but levels oscillated wildly as new surface and mantle cycles appeared. Study of zircons has found that liquid water must have existed as long ago as 4,400 million years ago, very soon after the formation of the Earth. This requires the presence of an atmosphere. The cool early Earth theory covers a range from about 4,400 to 4,000 million years ago. A September 2008 study of zircons found that Australian Hadean rock holds minerals that point to the existence of plate tectonics as early as 4,000 million years ago. If this is true, the time when Earth finished its transition from having a hot, molten surface and atmosphere full of carbon dioxide, to being very much like it is today, can be roughly dated to about 4.0 billion years ago. The actions of plate tectonics and the oceans trap vast amounts of carbon dioxide, thereby eliminating the greenhouse effect and leading to a much cooler surface temperature and the formation of solid rock, and possibly even life.